So the particle rests on a smooth horizontal surface. 3 horizontal forces of these magnitudes. So this is a bird's eye view. These are horizontal, and we're looking down on the particle which is resting on the table. The particle is in equilibrium. Find theta and F. So I want to break it up if I can, so I can just get one unknown. I don't want to resolve vertically because I'll have an F and a theta. So the first thing I'm going to do is resolve horizontally, and it's in equilibrium, so that means the left hand force must equal the right hand to the right. So that's 2.4 equals, and that'll be 2.5, and if I split this force up like so, this is the one I want here, and that is sine. So it's 2.5 sine theta, and therefore sine theta equals 2.4 over 2.5, and so theta equals 73.7397 degrees. That's what founds theta, and now I want to resolve vertically. It's in equilibrium, so the upwards must equal the downwards, and upwards is 2.5 cos theta, and that must equal downward, which is F. So F equals 0.7 newtons. That's just that bit. And the 2.4 Newton force suddenly ceases to act on the particle. So that bit disappears. Just at that bit, find the magnitude and direction of the acceleration of the particle. Well, you could just look at these two forces, that force there, and this one here we just worked out as 0.7, and that's 2.5. You could do it this way, and that angle there we worked out was 73.7 degrees, and find out that, and then use resultant force is the mass times acceleration. But it's easier to work out this because what's happened, they've taken away that force there. It was in equilibrium, so if you take away that 2.4 Newton force there, the force now, the resultant force must be 2.4 to the right, because the blue forces and the pink force, which I had here, must obviously cancel each other out. So if I take away the 2.4 here, this bit will be 2.4 to the right. So magnitude and direction of the acceleration force equals 2.4 newtons to the right, and we want to find out the magnitude and direction of acceleration. Therefore, acceleration to the right, and what we got 2.4 equals the mass, which is 0.2 times the acceleration. So the acceleration equals 12 meters per second squared, and I say it's to the right, and that's question 2 done.